Good morning everyone. My name is Neeraj Kumar. Today I will discuss about signals and systems. So first we will look about the topics which I will cover today. So first topics which I will cover is introduction of signals. After that I will discuss about types of signals. Then graphical representation of continuous time and discrete time signals. After that I will also see about introduction of systems, then types of system and their examples. So first see what is the signals. Signals describe a wide variety of physical phenomena. Information in a signal is contained in a pattern of variation of some form. For example, in simple RC circuit, the pattern of variation over time in the source and capacitor voltage Vs and Vc are examples of signals. See here in this circuit, variation in the voltage of the source Vs and variation in the voltage of capacitor Vc are examples of signals. Here an automobile responding to an applied force F from the engine and to the retarding frictional force rho times V, where V is the velocity of the automobile. The patterns of variation over time of the applied force and resulting automobile velocity are signals. Signal is a function of one or more independent variables such as time, distance, position, temperature and pressure. For example, a speech and music signals represent air pressure as a function of time at a point in a space. A black and white picture is a representation of light intensity as a function of two spatial coordinates. In this course, we will focus our attention on signals involving single independent variable. For convenience, we will generally refer to the independent variable as time, although it may not in fact represent time in a specific applications like geophysics. See, there are two basic types of signals. First one is the continuous time signals and discrete time signals. This is the another type of signal. In continuous time signals, the independent variable is continuous and these signals are defined for continuous values of independent variables represented as x of t, where x is dependent on independent variable time t. Example, a speech signal as a function of time and atmospheric pressure as a function of altitude are continuous time signals. Discrete time signals, see, are defined only at discrete times. For these signals, independent variables takes on only a discrete set of values represented as x of n, where n represents discrete independent variable, time takes only integer values. For example, demographic data refers to socio-economic information expressed as statistically including employment, education, income, marriage rates, birth and death rates, etc. These are examples of discrete time signals. See, these are graphical representation of continuous time signals and discrete time signals. See, continuous time signals are defined for each and every values of time. See, on the x-axis there is a time independent variable, and on y-axis the values of the signals, and the signal is defined for continuum values of time. But in case of discrete time signals, signals are defined at discrete values of time, that is only integral values of time. Similarly here, time is represented by letter n, and x of n represents the values of discrete time signals. Here, system is viewed as a process in which input signals are transformed by the system or cause the system to respond in some way, resulting in another signal as outputs. For example, a high fidelity system takes a recorded audio signals and generates a reproduction of that signal. Means a system processes input signals and then gives some response, that is output. Next is types of system. Systems are of two types: continuous time system, in which input signals and output signals both are continuous time signals. For example, radio, TV. Discrete time system, this is another type of system in which both input and output signals are discrete time signal. For example, calculator. Any questions, please? Thank you.